Hello, cuties. Okay, that's weird. But there's this question that we've been trying to solve since like the day before yesterday, and I just have zero motivation to solve it. So okay, yeah, I've tried everything, honestly. I mean, not really. It's not about me trying everything. It's just about me, like, not having the motivation, as I said. But yes, we gotta do it. So, this is the question, and I think the question is pretty straightforward. We've been doing binary search now. So, what they've done is that they have sort of, rotated the array. So, instead of starting from 0 over here, they're starting from here. So, that's what we're dealing with. And we have to find the location of the target. So, given any element, we just have to find its location. Here it's not there, so cool. So that's what we're trying to do. I obviously went to Leetcode. I tried everything, but I just couldn't make myself be there, focus, and do it. Okay, so here we are. I've told him, teach me how to solve this, please do, like, just teach me. And says it's a great question because it's just agreeing with me probably, and so let's start. Okay, so I'm gonna read all of this. We're gonna learn how to code it, and life is gonna be awesome. Okay, so problem summary: we are given an array nums that is sorted but rotated at some unknown pivot, right? A target integer, yeah. We need to return the index of target if it exists in nums, otherwise return -1. Awesome. Okay, so that's the question. We already understood it. Key insight: normally in a sorted array we just do binary search, but here the array is rotated. Okay, so it's not the worst case scenario where it's scrambled, it's rotated, so something must be there. Still, at least one half of the array, left or right, is always sorted. We can use this fact to decide which side to search. Okay, interesting. So we're basically like having sides over here, and we could apply binary search within that. Okay, fair enough. Approach is a modified binary search. We are going to set low is equal to 0, high is equal to n-1. While low is less than equal to high, find mid is equal to low plus high by 2. If nums mid is equal to target, return mid. Check which half is sorted. So if nums low is less than equal to nums mid, left half is sorted. Now check if target lies in that half. Okay, this is a bit confusing. So what we did over here is we found the mid. Okay, so in this case it would be low would be 0, high would be, I think it is 7. 0, 1, 2, 3, 4, 5, 6. Okay, 6, perfect. So n-1 would be 6. So 0 to 6. So that would be 6 plus 0 by 2. That would be 3. Okay, so 0, 1, 2, 3. This is the center. This is mid. Now, if mid is less than equal to, if nums low, okay, our target is 0 in this case. So if nums low is less than equal to nums mid, which is true, that means the left half is sorted. Perfect. This makes sense. Okay, now check if the target lies in that half. Awesome. And if nums low is less than equal to target is less than mid, search left. Okay, wait, this is a bit confusing. Nums low is less than equal to, is more than equal to. Nums low is less than equal to target and is less than nums mid. So target lies within 4 and 7. Search left, that is high mid -1. Okay, else search right, low is equal to mid plus 1. Perfect. Does that make sense? Yeah, I think it does. Okay, so in this case, what would be the scenario? In this case, we would be talking about low being mid plus 1. Perfect. And then we would move over here and we would say this is true too, and then you would search in that. If not found, return -1. Okay, so I think this is our approach, and we could actually try solving it on our own without seeing the code. So this might take a little longer than expected. Okay, longer than expected, more like I'm expecting a lot of time. Okay, that's a lot of lines. Okay, no, I don't like this type of commenting. Wait, are you seriously? Yeah, it's simple. This and then command /. Awesome. So what we're gonna do is we're gonna say int low is equal to 0, Wait, aren't we gonna pass something? No, probably not. Okay, int low is equal to 0, int high is equal to nums dot length minus 1, while low is less than equal to high. Do this, do this, do this. Wait, don't we want a binary search over here? I think we do now. Okay, I could have just done it before, girl. Yeah, okay. So what we're gonna do is we're gonna say modified return modified binary search nums comma 0 comma nums dot length minus 1 and target. Okay, and that'll be the end of this. Okay, cool. And over here we're also gonna need that, and then we're gonna say public int modified, oh girl, int nums, int low, int high, int target, and inside we say while low is less than equal to high, I mean, here we could also say, okay, let's just go ahead with that. Int mid is equal to low plus high by 2, and if nums mid is equal to target, that's like our best case scenario ever, then what are we gonna do? We're gonna return, oh my god, return mid, right? Yeah. Okay, now comes the important part. Else if nums low is less than equal to nums mid, then we're gonna do what? We're gonna say, now we know that it is increasing over here, so we've stopped over here and it's increasing like this, so we want to check if that, we want to check if the target lies in that half. So if, oh my god, if nums low is less than or equal to target, which is less than, so here you do and target is less than nums mid, okay, then we're going to do this modified binary search for what? For nums comma low comma wait, we're gonna search in that half, so yes, low comma mid minus 1 comma target. Okay, that looks sweet. And otherwise, if it's not the case, else we're gonna say low, I mean, we're gonna still do modified binary search, right? Yeah. Nums comma mid plus 1 comma high comma target. Okay, awesome, perfect, this looks good. Okay, and once we have that, we want to check this. Okay, so this is the case when nums low is less than equal to nums mid. Another case could be where nums mid is less than equal to nums high. Okay, so say this one was your mid. Okay, wait, Who's that man that's holding your hand and talking about your eyes? So this case, so see, this case where we have 1 over here, okay? And will this work? Nums low is less than or equal to nums mid. No, it won't work. So in this case, we need another condition. And what is that condition? Else if nums mid is less than or equal to nums high. Okay, so this means you want to search over here or else you want to go back. Okay, so in this case, what will we do? That if nums mid is less than equal to target, oh my god, and and target is less than nums mid. Okay, if these, nums high, I was just copying from the top. Okay, nums high, then what are we going to do? We're going to do modified modified binary search from nums mid plus 1, okay, to high, right? To high to target. To target as in for target. Okay, cool. Else, if that is not the case, if target is not between 1 to 3, say target is 9, then what do we want to do? Then we want to do modified binary search for nums from low, basically on the left side, low to mid minus 1 to target. Cool, awesome. I think this code looks perfect. Okay, we are returning stuff, else we are doing this, else we are doing that. Looks good. We are returning this. I'm super confident with this. I hope there's nothing wrong. Okay, there's something wrong. Okay, I'm talking about your eyes. Bro, I hope the code's saved. Oh my god! Oh my god, I cannot do this. Girl, I was logged out. I wrote the whole... Okay, it's back. Oh, okay. I freaked out for no reason. Okay, this has been super entertaining and we have been super weird. Okay. Oh, okay, that's an extra bracket. No, there is in fact a return statement. Oh, right. Oh, I do this so often. I never do this. This is so dumb. You obviously are returning that function for it to be recursive. Okay, I think it's good. I think we shouldn't have been that confident. Oh my god, girl, what do you want? Take my life. Return -1. Because in that case, we want to return -1. Okay, yeah. I hope there's nothing silly like TLE or something. Okay, that's not very yay. Yeah. Huh. So we must be going wrong in one of the cases or something. This case would be where we found this was the medium, and then we were like, if nums mid is less than equal to nums high, then if nums mid is less than equal to target, and target is less than nums high. Okay, less than nums high, yeah, and then nums mid plus 1 and high, so that would be low is equal to high, and then we would be at mid is equal to high plus high by 2. That would be high. I mean, that would be, yeah, high. So that would be 2, and then we would be like nums 2 is equal to target, which is 3, so return 2. Why are we returning minus 1 over here? We literally said equal to. Should we make it this? I don't think it'll make a huge difference because we're good. I mean, yeah! Oh my god, girl, let's go! Okay, making this video was so much fun. I hope you enjoy it too, and I hope you understand this. I've been super weird in this video, so but yeah, who cares? It's okay. But yeah, I hope you understood the main concept over here. We are returning this modified, and we just have a bunch of if-else statements that really help us get the solution. So I think it's a super cool code. So instead of having just one set of this, we sort of have two because we're separately searching it twice. That, I think, is the main concept. So as they said over here, that at least one half of the array is sorted, so we can check for those halves. Okay? Which side to search. Awesome. Cool. I think this must be very close to what we did. Yeah. Okay. Nice. Bye.